The thing about these problems is we don't always revolve around the x or y axis. Sometimes we revolve around lines that are not the axes. So what do we do? So when we want to find r, it's going to be a lot like our area between two curves. We need our top equation and our bottom equation. We need our top equation to tell us the height from the farthest point away from our axes here. Our bottom equation is going to be that part that we want to get rid of. So we're going to use that same idea of top minus bottom to find our radius here, the radius that we need that we're revolving around our axis. So in order to find r, we are still going to do f of x minus g of x, top minus bottom. So for horizontal rotation, we're going to do f of y minus g of y. So that rightmost equation minus our leftmost equation for vertical. The other thing that you need to know is that that second equation, g of x or g of y, are generally going to be lines or axes that we're rotating around. So it's generally going to be a number. So like in our problems from before, g of x or g of y was always 0, which is why we ignored it. Now it's not going to be 0, so we want to look at what to do with it. So find the volume of the solid that results when the region enclosed by the curve is revolved around the given axes. The given axis, so y equals 2 minus x squared, y equals 1, x equals -1, x equals 1, and the axis of y equals 1. So the axis that we're revolving around is this axis of y equals 1. So we're revolving around this axis here. We have our bounds, so we don't have any volume, or we have no area down there, so we're not going to add in that piece. We are looking at -1 to 1 for x, so we're only looking at the bounds here. So our a and b are going to be those two pieces there. So a is equal to -1, b is equal to +1, and then our radius, r, is our top equation minus the bottom equation. So our top equation, f of x minus g of x. So f of x is 2 minus x squared. G of x is 1, so that's what we are going to subtract from it. I can go ahead and simplify this. We have 2 minus 1, so 1 minus x squared. So this is what we want to integrate. Our radius is 1 minus x squared. I could also put all of that in and do what we've been doing. So our volume is equal to pi times the integral from a to b of r squared dx. So we have pi times the integral from a to b, which in this case is -1 to 1, of r, which we have 1 minus x squared, what we found, but we need r squared dx. So just like all the other problems, I can multiply this out, I can do all of those things, integrate it, then plug stuff in and simplify. But we're focusing on the setup. When we do that, we are going to get that this integral is 16 over 15. So we have pi times 16 over 15. So 16 pi over 15. So it's a little bit over 1 times pi, which would make sense for this area. Find the volume of the solid that results when the region enclosed by the curve is revolved around the given axis. Our axis this time is y equals -2. We have y equals x squared minus 2. We have y equals -2 and x equals 2. So looking at this function that they gave us, looking at this graph, we can tell that we're hitting 0 for our x. So we have our bounds of 0, to 2. We are looking at things that are above -2, and our axis that we're spinning around is -2. So A in this case is 0, B is equal to 2, and R is going to be top minus bottom. Our top equation is that parabola, so we have x squared minus 2 minus our axis of revolution, which in this case is -2, so we're going to subtract -2. In doing so, we're really adding 2. So we have x squared minus 2 minus -2, or x squared minus 2 plus 2. So if when you simplify it, it just equals x squared. So our volume is equal to pi, the integral from a to b of r squared dx. So pi integral 0 to 2. R is x squared, but we want r squared. This is the same thing as integrating from 0 to 2 of x to the 4th. If we integrate it from 0 to 2, we get x to the 4th antiderivative is x to the 5th over 5, and we want to evaluate it from 0 to 2. We're going to plug stuff in. Pi 2 to the 5th over 2 over 5 minus 0 to the 5th over 5. 2 to the 5th is 32, and we're dividing it by 5. The other piece will go to 0. So we have 32 pi over 5. So if we look at what we have here, this actually makes a lot of sense, because this problem, compared to the very first problem we did, is the exact same thing. The only difference is we took this graph and we shifted it down 2 units, but we also shifted our axis of revolution down 2 units. So it makes sense that this would give us the same area here as it does here.